Hey guys, we are going to get started in few minutes. Hey guys, we are going to get started in few minutes. Hello, little bit. Thank you for joining. Thank you everyone for joining. We'll get started in few minutes. So let's everyone gather. Yeah, we are waiting for everyone to come in. We'll get started. We'll get situated meanwhile. So folks, thanks for coming in. We are getting started soon. So what you are watching is actually a live footage, but this is from the past, not from now. This is how you should be able to see it. I'll show you guys where we are with our findings. So we'll let everyone come in. We'll start talking about what really happened there, why we could not see it. Why we could not see it. We are going to get started. Let's give few minutes for everyone to come in and we'll start. So the images that you are looking at right now are from the past, not from yesterday's impact. I want to make sure that you are aware of that. I'll show you guys the details that we are capturing right now. So we are looking for the VLT signature. So the very large telescope. So good evening everyone, thanks for joining. I think we'll get started. There is quite a bit to cover today. So we'll try as much as we can. There is quite a bit in there. So what really happened? So I've turned off the music so you can hear me well. So thank you everyone for joining. Thank you, thank you. Yeah, so hello Reliance and hello Cosmic Rays. Thank you everyone for joining. Yeah, so if you guys are if you joined yesterday's stream, live stream, what we are dealing now is we live streamed last night. We went through all the details of capturing the impact, and what we were told at the time of impact was we should be able to get a decent capture of the impact. That's really what we were told. This was, as of yesterday, what we were looking at is to be able to see the impact itself, and we were all waiting to see whether the impact did happen or not. We were all trying to focus on the Einstein crater. This is the crater. If you, I can zoom in a little bit more. So this is a crater where it is actually supposed to happen. That did not happen. That particular crater, we were watching very, very close, and wherever this is supposed to hit, it did not hit. And we figured out that something else happened. Well, the first thing that happened was it didn't hit that crater, but it happened to hit a little bit more western side. We'll go into that details as well, meaning right now you are seeing that crosshair. So beyond the crosshair, the place where we cannot use our telescopes and we cannot watch, essentially that's where the rocket, the second stage rocket, came and hit. Now, there are multiple reasons that they came up with this, why we could not see it. Some of them essentially are theories, and some of them are to be proven, like in terms of like how, what needs to be done, like to understand what's going on there. The main thing that did happen over there was they came in with a recalculation of what really happened, and during the process of recalculation, they figured out it's actually in fact coming in very, very slow than what is anticipated. It's still that 2.17 kilometers per second, that still holds true, but it seems that speed was not sufficient for us to see the brightness of this object. That was one reason why we could not see that object. That was one reason. I mean, which was kind of like pretty much anticipated. We know like this is something that probably cannot see using our ground-based telescopes, because it's going to be like a much, much, much smaller impact. So if you wanted to see a visualization, not a visualization, a real impact, how it is going to look like, let me see if I can bring up that video. So normally when you see a lunar impact flash, a flash is going to look something like this. Okay, so let me close this, guys. Give me a second. So a flash is going to look something like this way, like where you should be able to see. There are multiple ways to take a look at this flash. I'm going to pause it for you guys. I'll slow it down. Okay, so let me see if I can, if I'm showing it correctly or not. Okay, so this is back in time, and if you see meteor, asteroid, or any of that going to come and impact the moon, you should see a flash like the way you are seeing it right now. And let me see if I can play the remaining flashes here. So this is one of the flashes. Let me see if I can, yeah. So this is like much more fainter than anything else. It's in the bottom of the screen, so probably it's, yeah. So let's take a look at this one. So you see this tiny flash on the, I'll move myself up. Okay, so are you seeing a tiny flash there? That is the flash that you are seeing when an impact is going to happen. I was expecting that kind of a flash from yesterday. I was thinking that we may be seeing that kind of a flash yesterday. That was my anticipation. I was looking for, we may be able to see a flash like that. It may not show you all the plume that you need, everything, but at least it should have shown us some kind of a flash like that way, right? That's not, technically that did not happen. We could not see that flash as well. So let me show you one more, if there is a way we can see it. These were, like you can see on the corner, like basically, so this is a very good indication of what it is. The reason why I brought this up was this is literally a comet, rocket debris when it fell on the moon. We were able to take a look at how the impact would be. And this is the very good simulation of a human-made object if it does impact on the moon. This is how it should have shown us the impact. That's what we were expecting to see in that during that impact. What did happen was it went into the other side of, not the other side, at least to a bit more to the side of the western rim, they call it, the northwestern rim of the moon. And the flash that came in not only is softer landing, even though it is coming in fast enough, but the brightness was not enough for us to see the brightness. And when it did landed, the rocket second stage booster, it came in and fell a bit away from the human eyesight or from the Earth vantage point, and the crater that it created, chances are it created in the corner. So let me show you guys one important piece of the puzzle that we were trying to solve. So let me bring this up. So this is the flash that we are looking at, and so this is from VLT. This is the image that came from VLT. This is taken from the flash itself. So on the right side, you are seeing the flash, which is the tiny flash there from the past debris. We still need to get some kind of a data point for us to see. What happened was our reconnaissance orbiter that was flying in that area is not in the same direction as where this impact was going on. It's actually kind of in a different axis, so it cannot come here and take a picture, at least for another week or so. The impact that it took was on the, I believe yesterday or day before, it took a picture of the likely area and it left. So we have a kind of a week before image of that area from the LRO, the Lunar Reconnaissance Orbiter. We don't have any post-impact of that orbiter at all. So what you are seeing on the screen right now is the sodium and the lithium. This is a spectrograph that was collected from imaging and enhancing the area where this happened. And they were seeing from the plume that came out, which is very, very important for us to know. So it did impacted at the time it impacted. Let me show you guys the date and time of the impact. If you are seeing some ads, I'm actually pulling up some news item that came in on this. So it came in 5,000 miles per hour. It's actually pretty slow compared to that. So the impact that came in gave us this 5 to 10 minutes after the impact, the plume still lasted, which is quite significant. If we had seen it, there were a couple of other images they were predicting to show you the plume as well. I'll bring that up. But you can see the miles into the, on top of the lunar surface, the plume did came out. So the sodium from the lunar soil and the lithium from the rocket is what we are looking at. When you guys are looking at, so this is from the top portion is coming from that soil, and the bottom is coming from the human-made lithium that is coming from the rocket. That's what we at least are now looking at. So these two confirms that the rocket did impact, and I believe the time, guys, can you all hear me okay? Can you all hear me well? Yeah, okay. Thank you, thank you. No, I saw a message came in saying that it was some kind of audio signal. Apologies for that. Thank you, thank you. Okay, so yeah, so what we are dealing right now is, this is what actually made me comfortable this morning. I got up early morning, I was thinking about how did we miss the impact last night. We were pointing our telescopes at the Einstein crater. I know, like, we are looking at it. My prediction was on the right side of the screen that you are looking at is, I wanted to see at least this kind of an impact. So let me go back a little bit and show you guys. This is coming in from a previous rocket debris, and let me play that. You see that the tiny flash, that very tiny flash, I don't know if you can see it or not. If I'm playing it, it comes and goes that fast. Let me do it again. Since I stopped it, you guys are seeing the flash, and I'm going extremely frame by frame. But this is how much the flash would be. It's like a small flash from the Earth standpoint, and this is taken using our space-based telescopes, space-based equipment. I don't know if it is LRO. It could be that US Spacecom 698. They are not telling us what equipment we have near the Earth that took the capture. They just number the thing. They don't tell us the space assets we have in the space or on the Earth as well. So these are all NORAD control numbers. So we just know that later on, that number 698 took the picture, right? So when you guys are looking at that picture, you are seeing that tiny flash. Let me zoom in for you guys. So when you see, the flash would have been like that. You see that a little bit of a tail kind of thing. That's exactly what we would have seen if the flash did happen, because it did fly in a 30-degree angle. We would have seen a flash like that if it is bright enough, because these are from space-based assets and they are so close to the moon compared to we using our telescopes from the ground. So chances are we may not be able to see it, but using the image that I'm looking at, we could go that close to the moon using our home telescopes. Our backyard telescopes are not small, they are pretty big. So if I get that kind of an image from the residential telescope, if that's the spot that it is going to create, this is your visualization, right? It's a true visualization of a rocket debris. If it does hit using your binoculars or telescope, if you do go closer to the moon, this is the size of the moon. Let me turn this off. You can see this. This is the size of the moon. That much we can go close by, right? So that means we should have seen from our telescopes yesterday that flash. Maybe it would have been like a very small moment. Look at the size of the moment. It could have been, we would have missed it too. Like there is no guarantee we would have seen it. But if I play it, let me play this for you guys. Watch that area carefully. That's it. What you just saw, that momentary flash, that's all you are looking at. That's the momentary flash. It's so fast. It's like less than, not even a second. It's like less than a few or maybe few milliseconds. That's what I have. I'm going to pause here for a second. Let me check the chat and see if you guys have any questions. Yeah, we would have stayed yesterday a little longer, but there is no point. So I didn't stay. So. Hey, thank you guys for coming in. Thank you for complimenting on the clothes. Yeah, thank you. So thank you for, let's continue. I just wanted to see if there are things that we did not see. Little bit appreciate that. Yep, we are good, okay. Yeah, if you guys have any questions in between, please do let me know. So anyway, coming back to the comet, the rocket second stage debris that we are talking about, we would have seen a flash that way. And let me bring up the flash here. So the details are incredible. One thing that made me comfortable this morning was I was not only disappointed that we missed the calculations, we didn't see, but we missed the calculations as well. How did that happen? So it explains now very clearly that we didn't miss the proof is here. Let me zoom in for you guys here. Yeah, the proof is here. So when it came in, it was exactly as predicted, as at 2:35 a.m. Eastern time, near Einstein crater as expected. So this is a good news for us in general, because this is telling us that we didn't seriously go wrong. That was a pretty good news, that we did a very bad math from our standpoint. We were able to see that 2:35 a.m. Eastern time, because 1:35 is when we were seeing it. So that's what the time we expected. So it would have hit the moon yesterday. That time, unfortunately, the brightness was way too low, and it did hit closer to where the sunlit is there. That's another reason. Maybe we could have seen some plume coming out. We did not see that plume either. It could have been temporary. What it said was the plume lasted for multiple seconds. So it's not like it didn't go away. It was there almost for 5 to 10 minutes, which is, we would have seen it. 5 to 10 minutes of plume. I don't know, depends on the angle of the plume too, right? If you are looking from the top surface, probably we would not have seen it. So this image that you are seeing on the top is when this rocket was launched on January 15, 2025. That was the image from the Cape Canaveral, the Florida launch station. That's where you are seeing that. So it is the one in the middle, not in the bottom, not on the top. So that section in the middle, the second stage, is the one which is there in the other images, which caused us. Let me see if I can show you guys that picture. Yeah, so you guys are seeing this picture. This is the one, that stage, the middle section of the rocket. That's the one that fell on the moon. And that's what we saw, a crash kind of thing. So there are a couple of more details that they did put in there. They said not only so here is the details. Yeah, so what we are expecting was 65, sorry guys, there are so many ads there. Okay, so there are 65 to 90 feet. Somebody is asking me that question earlier, right? 65 to 90 feet, which is 20 to 30 meters, depends on which side of the planet you are. So 65 to 90 feet or 20 to 30 meters, it must have impacted. So the crater would have been 100 feet deep, which is substantial amount of crater size. It's very visible, obviously, when you are looking at a crater of that size. We would get a picture of that crater very soon, and we can see that impact. Okay, so I do wanted to comment on one important thing. There is a stay tuned for my either live sessions or videos on the channel. I will be posting it soon. There is a new finding. So okay, I want to step back a little bit. So when this station was sending this rocket out there, the mission of this particular rocket launch, which was successful partially, at least 50% successful, was to send 2 lunar landers. Okay, so one of the lunar lander was successfully landed on the moon, and it is sending pictures. And the picture is so weird. So I wanted to show you guys those weird looking kind of odd pictures that people are looking at. And I mean, nothing extraordinary, but it's just odd that we were looking at a picture like that. So I'll show you guys that picture when it landed. So when they are talking about this when they're talking about the 65 to 90 feet deep that it created the impact, you can actually see the visualization of what this is carrying, how heavy this rocket second stage was. If the people are saying if there was a little bit of a fuel left from the second stage standpoint, it would have course corrected and it would have brought back to, like, at least crash landed, I guess, at least back onto the Earth, not on the moon. So that was one of the things that we are realizing now, which is fairly interesting. So now here is the deal. Is the impact visible from naked eye from the Earth? No, it is 225,000 miles away. So there is no way, even telescopes you can see it. It's going to be, you can see on the right side of my screen that I'm showing, if it did created a crater, we can see the crater. At some point of time, if that crater is maybe visible, it's on the other side. So I don't know. At least the LRO would take a picture, but we should be able to see a tiny bit of that crater using our powerful telescopes from our backyard. We should be able to. But not where this rocket debris launched, because it was a little bit on the western rim. So chances of us looking at that side, unless we physically go there, moon doesn't orbit like the way we wanted to see. It is a tidal gravity with the Earth. So we won't see that side unless we become an astronaut and fly around. We won't be able to see that, unfortunately. But at least the LRO image, when that comes in, they should be able to show us that image, hopefully. That's what we are expecting now. So I'm going to pause here for a second, see if there are more questions coming in. There is a couple of more. I'm going to run this. Guys, this is something which is weird. You must have seen this. So whoever is doing this for fun, I must have shown this to you before. So this is back in 2006. It's from one of the NASA's archive. And this is some kind of an aeroplane. Somebody was taking a picture of it. And I'll show you guys a little bit. It's fun to watch. Yeah, so you should be able to see. And this is a NASA's video. They called it UFO, which is actually interesting that they wanted to call this as, there's a reflection on the top of the screen a little bit. Probably you won't be able to see it, but that looks to me like, I probably must have shown this to you guys before. So yeah, this is coming from an older version of a video. So anyway. Okay, I'm looking at some of the questions. I wonder if this is going to cause a 7 second of, no impact whatsoever. Zero impact from our vantage standpoint. What you're looking at on the screen right now live is tiny bit of flashes, and that shows you how you will see in real time the images that are, at least live view or images, whatever you call it, when the flash ever happens, right? Disclosure, it's a plane. Yes, it's an aeroplane. Oh, a little bit. Thank you. Appreciate that. What was... Yeah, guys. So, yeah, this is pretty much what we are looking at on this side of the thing. There are a couple of more things that I have seen that I wanted to show you guys. See, this is the impact where, let me close this for now. I don't want to bring it back. Give me 1 second. So what we are looking at is if there is an impact. A lot of people, when yesterday they were asking me and looking at the images and people are posting it, they would love to see an impact something like this. This is what people's visualization was. Maybe we will see something like that will happen. Unless you are actually standing on the moon or you have some kind of a device that is looking at the impact from a very specific photographic angle, we won't be able to see it. And even, I wanted to pause and show you guys, look at the size of the asteroid that is falling, and that will show you that much of impact. I will pause here for a moment. So if you are seeing a huge, sorry, I will try to pause. Okay, if you are seeing a huge asteroid that is going to impact the moon, you should be seeing a visual like that, which is extremely rare. We have not seen and recorded that size of an impact, at least real time. And the previous video that I played for you, where you are seeing those tiny flashes, are the only flashes that we have recorded, at least from the moon's impact standpoint. That would have been a huge impact, what you are seeing right now. If that is the kind of a flash you are looking at on the moon, that means it's a very big object that is colliding the moon and also coming at a much rapid speed. I don't know if they put in the speed here or not. I don't think so. Yeah. So yeah, it is coming in probably like 70 kilometers per second or above, and almost like a comet or a asteroid kind of an impact. And that is kind of an impact that you would see. And the impact is here a lot more on the moon, because moon does not have any atmosphere. It doesn't show, like when you watch this carefully, you don't see the asteroid getting hot, like as if it, that's not how you will see it when it comes closer to the Earth, right? You always see it is almost burning inside the atmosphere a lot. Here what happens on the moon is, if it is a second stage rocket or if it is an asteroid, if it's meteor, they fall like the way they are, and you only see the crash happened or the heat getting generated only after the crash. If maybe a tiny bit hotter because of the getting closer to the gravity of the moon, but you don't see the style of the impact that we normally see on the moon, normally see on the Earth. This is kind of very unique to the Earth itself. Yeah, no atmospheric friction, that is correct, period. Once it does impact, it is going to have completely vaporized, or it turns into that dust on the moon. That's pretty much what typically happens. We did left some cameras, journal for, actually I was watching, if I can show you at some point of time, like I'm working on a different video and I was looking at an interview of Neil Armstrong, and Neil Armstrong that was his last interview. I love listening to him because he's like a genuine man, talking about all his experience and all that stuff. And you can look up on the YouTube yourself. This was Neil Armstrong's last video. He went to Australia to get interviewed, and he was proudly talking about his 40 years of life after he landed on the moon, like post astronaut life. He was part of a board of directors of a huge organization, and I believe at the time when he was talking about people who have these conspiracies that did we really land on the moon, right? So I was like waiting for that question to come up. This guy is so close to Neil, he's not going to make him disrespectful that way. But luckily, what happened was he did ask that question. We all wanted to hear what he wants to say. So, yeah, 1966, the comet is back of my tongue all the time. I take pictures of so many asteroids and comets. I guess, I don't call rockets a lot. So it takes a while for me to get used to the word rocket rather than comet. So yeah, 90% of the time I'm working on some planet or comet or asteroid. I don't typically work on rockets, so that's why that's not part of my thing. Good observation. Okay, so I believe Neil, I was waiting for the response from Neil, and Neil came back, said, I think he's actually took it more lightly, and he said they should go and look at the camera I left there, which is pretty confident that he was able to say that he, at least, I mean, I don't know, I'm not a very good expert in body language, but when you are looking at a man who is proud at, I guess, after 40 years, and the way he said it tells me that he is quite confident in what he is trying to say. It's not that I'm not believing it, but when I'm looking at his face, people should have seen that kind of a face prior also, and maybe they should have stopped that conspiracy. The other part that I learned from that video, which I never saw before, was they were talking always about like, look at the astronaut faces when they came back. They look pale. They have no smile on their faces. They achieved this once-in-a-lifetime event, and they didn't say anything. Or they are not smiling or cheerful. That's not true. Actually, that video, the Australian video, did prove that they were actually in New York, and they are going through a parade. They are having cheerful voices. So it kind of gives you a different kind of an impression. I think we can do one day that video while showing you the live images of the moon. Maybe that will help at some point of time. We'll do that. But anyway, I just digressed a little bit talking about this. So anyways, unless you go physically to the moon and capture, you won't be able to see an impact of this way. The plume, unless you have a orbiter or some kind of object you have at a sensor that is taking captures, you don't get anywhere near this. The plume that is going to come out depends on the angle of the pictures that we are going to get. We might see a tiny bit. That's pretty much what we are expecting. But we should see a decent crater. That's what we think at this moment. Let's see how that is going to turn out to be. Yeah, there is another. This is the L-cross lunar impact. You must have seen this before. So this is something I'm working on. If I can show you guys quickly. So this is, I'll fast forward this, guys. This takes a very long time. It's like really, really, really slow. So this is basically the camera on the L-cross when it is falling on the moon. It is literally taking picture by showing how it is going to look like. This is a real-time capture, and I believe it goes really slow. I'm not sure why. I think they must be turning into maybe taking one screen at a time. Hey, Steve, thanks for joining. Thank you all for coming in. So if you guys are just joining, please do subscribe to the channel. What we are watching right now is a previous impact mission. This was a deliberate NASA impact. It's actually sending something on the surface of the moon. While it is sending it, it is capturing the mission itself. That's what we are watching. It is crashing into the moon. That's what we are looking at. Angle chain, thank you for joining. Yeah, that's what you're looking at. Sorry, I was on mute talking. Thank you. Thank you. I totally forgot. Thank you. No, I was saying it's very slow, the video. Yeah, there are a few more things to discuss while we are here. I just wanted to show you guys, this is the live backyard view of, we are watching it live. This is the backyard view. It's actually very interesting. We can see the Milky Way on the top. I just brightened it up a little bit. You can see that. This is in the city. It's, a little bit suburbs of the city. But you should be able to see maybe it needs a little bit more focus, I guess. But I think you can see the live images itself. It's very interesting. So, by the way, we are still imaging the comet 10P temple. That's today is the brightest day, one of the brightest days. That I believe starting tomorrow, it will get slightly dimmer. I don't think it is going to get way too dim, but it will get dimmer. That's what is going on there. So I'm actually taking pictures of those. So people who wants to hang in here, definitely please do stay. I will try to bring in those images as well. I'll keep the music on. If you guys have any questions, I'm watching the chat. And I will try to bring up the comet itself meanwhile. It's very interesting, guys. If you wanted to know about that comet, I'll bring you the website. So we are building a website, and for our Reliance.com website, and yeah, what you are looking at is, I believe I should be able to show you this. I think so. Yeah, right here. So it is still 38 million miles, comet 10P temple. This is the closest point to the Earth today. It is the brightest point right now. It's still not very bright. So these are the ones that we are seeing. And that 12.77, today is August 5th. Yes, today is August 5th. So we are looking at today as being the brightest day for this comet. And this will not happen in the next 100, 200 years or whatever the time frame is. It won't come this close to us. Yeah, so we'll be capturing some pictures of this comet. That's what we are working on right now. So you got the message regarding the Falcon 9. I have a lot more data points I can bring up. Let me work on setting up this, and I will try to bring up the more data points for the Falcon 9. Okay, give me a few minutes. Let me complete this. If you are wondering what's going on, we are taking pictures of the 10P temple. I'm really sorry. So, yes, I wanted to step back a little bit. So, I believe I was talking on mute. So, what we are looking at now is taking a picture of comet 10P Temple, and the previous screen where you saw we were downloading the latest coordinates. I promise you I'll stay on this technical topic for 1 minute. The Earth itself is like wherever you wanted to go, you have a latitude and a longitude. Similarly, from the space objects, whether it's comets, asteroid, planets, anything, there is a celestial sphere, kind of imaginary sphere around the Earth. So it's not really there, it's just an imaginary sphere, and we have locations on them, right? So those are these locations. We don't call them latitude and longitude. We call them RA and the deck, which is right ascension and declination, and I'm doing that. Thank you. So if you guys stay for a few minutes, we'll connect this and then we'll go back to the discussion that we need to complete on our Falcon 9. Thank you. Guys, give us a couple of minutes. We are going to that comet, and once we are done with the comet, we are going to come back and look at the more data points on what happened. With that Falcon 9, we'll go back there. Guys, you're watching this live. We are trying to go to that comet. So hang in there for a couple of minutes. We'll go back to what happened to the rocket. You're seeing Milky Way, by the way, in the back. Give us a couple of minutes. We are going to that comet and then we will move. So, for the people who just joined, the rocket did hit the moon. I keep saying it's comet, but the rocket did hit the moon as planned, as last night at 1:30 Eastern, 1:30 Central Time. And it hit where it is supposed to, which is Einstein crater, but a little bit more towards the west, where it is not faced towards the earth. That's what was going on. We could not see it. What we know so far is we know that we have a live confirmation of data from very large telescope array, which did a spectrograph, and it did show that we were able to see the signature of the moon-based sodium and the rocket-based chemicals as well in those signatures, so which is telling us that it did in fact hit the earth. They also said the plume lasted for 10 to 15 minutes, which is incredible. Which is really incredible. So this is the So now what we are looking at now is, I wanted to show you guys, if you haven't seen, the type of the impact that it happened. And how it is supposed to look like. Sorry, I'm making it slightly brighter. I just want to see where the scope is. So if you're wondering what's going on, we are going to the Comet 10P temple, and if you wanted to know a little bit background on that, today is while it is doing whatever it is doing, I want to show you quickly. Today is August 5th, 2026, and today is the brightest day for this comet. I mean, it's going to slowly get dimmer and dimmer. You can see those numbers on the screen. Magnitude, lower magnitude means it is going to it's not going to be a huge comet. So don't be disappointed when you see it. It is going to be a tiny comet. This is the reason why we are taking this picture, is because it won't come in the next 100 years. And this is the first time it came in the last 100 or so years. So it's kind of cool that it is a 10-kilometer comet came this close to the Earth, and we are taking a picture just for the record. I mean, probably somebody else must have taken it anyway. But for us, we can see with our own eyes how these comets are going to behave. I mean, for you to understand, there is a bit of a thing about these comets, okay? Particularly these kind of ones. So if ever we eventually might become, I guess, a bit more advanced civilization than where we are, we might end up harvesting some of these, because these are the ones that provides, I guess, lot more resources that maybe on the go. So these are definitely the ones that we might use as our tools in the chest, right? Basically, that would be one way to look at it. The other way to look at is, it's kind of weird that we are getting to know how these comets and asteroids that are inside the solar system now are out here, like the way we are seeing. The new theories that are suggesting now is some of these are coming inside the solar system and staying here, not because that's the way the solar system was designed. They were saying there is a nearby star that was passing by the solar system and did disturb the objects out there in the Oort cloud, which is around the solar system. And the new theory now says that some of these objects that we are seeing, these Jupiter comets and stuff that is inside, and all these asteroid belt and all that, is probably coming from that disturbance. The second theory that we currently have is these are all like some kind of a debris from a planet that exploded or impacted and got into trouble. So that was one other theory that we have. Those are the two major theories. Why we are seeing so many of these inside the solar system, all those comets as well. So that was one of the theories that people talk about, how these comets are happening. There is an angle that I was looking at when I'm looking at some of these objects, is there is something called dark comet or dark asteroid or whatever you call it, okay? So when they call it dark comet, technically they are asteroids, they're not comets, and they suddenly woke up, right? So if you see an asteroid out there, and that asteroid suddenly now became a bit more gaseous, and it started releasing some kind of something, and they call it that as a dark comet, and those are the ones that are very dangerous for us. I mean, which is, if there is something that can happen to the civilization that we are in, those are the ones that somebody might capture and move them around, because that's the best way to travel. It's free fuel to come and go. So those dark comets are a pretty sensitive areas where we need to look for, hey, did it suddenly woke up? Yes. Give me 1 minute. So right now the telescope is going towards the comet. It's on the northeast side right now. Actually, sorry, southeast side. So it's going to, the cat house that you're seeing here, it's going to point on top of it. There is a video that I'm making. I could not do it today. I was stalled. I wanted to share a little bit excitement on that one. I did downloaded some extraordinary amount of data, and I'm going to share with you all. It's going to be an interesting thing. I want to see how you all feel about that new video. I'll give you some clue. It is about the dark structures or whatever you call it, structures on the moon, right, on the dark side. It's a very interesting video. I'm not creating a video for fun. This has a bit of a science and everything else into it. So it's pointing towards the cat house and it's on the top. It probably didn't even come in yet. Probably it's on the pretty low side. We'll see. When it takes a picture, we'll get to know where it is. So while we are waiting, I do wanted to add one important thing about yesterday's Falcon. What they just confirmed is the crater that it created, the big crater, the 100 feet deep, because of this Falcon rocket impact. They are saying that that crater will not be visible from the Earth. The resulting crater is, first of all, it is too small. That's what they are saying. I believe some data must have came in, and it is only by the LRO, the Large Lunar Reconnaissance Orbiter, can only take that picture. The crater is small. Even though it's 100 feet deep, the size probably is quite smaller. That's what they are saying, that they are confirming that we won't be able to see the crater using the ground-based telescopes, which is very interesting. I was thinking that we might even at least see a little bit of it, which is fine. I mean, that's what it is. That's what it is. it would be interesting if we would have seen it, like in our lifetime, we would have seen a crater being made. I don't know what they will call it. They will call it SpaceX or something. So, but anyway, the point is, I don't know what's the name of the crater. I have not done the homework on crater. Definitely there will be a name. And the most important thing though, I wanted to tell you guys this. The lunar orbiter that it took, that lunar orbiter is a very interesting orbiter. It is taking some decent or interesting pictures, and we are working on it separately to understand what it is doing. Yesterday when we saw the moon, it was almost illuminated, right? So yeah, it's like so. So there is a orbiter that we found besides the So there is a Korean, from Korea, South Korea, there is a orbiter similar to the US orbiter on the moon, which is orbiting around the moon. The name of the orbiter of Korea's moon is called Danuri, D-A-N-U-R-I, Danuri. What it did was it passed within, I believe, few kilometers, right? Literally 2 minutes before the impact. So chances are it may have taken the picture of when the rocket was flying towards the ground. We may have seen, we may get a picture. We will see if we can get hold of the raw picture of that Danuri, which is the orbiter flying around the moon, must have taken a picture. So we should be able to get a picture of that Falcon 9 rocket. All right, I think we are off to go. We don't need to touch this subject anymore. It is going to do its magic, and we can continue rest of the stuff. We can come back here, which is good. Thank you for. We will see those images. I do wanted to keep. Last evening, you are right. I would rather that's what is happening. I was pleasantly surprised by how many people were tuning in, not only from the US, 2036 impact. Oh, that guy, by the way, I like your logo. You're from Texas, I believe, right? You're putting our. Okay, so yeah, we'll see. I mean, it's going through a gravitational hole, the Apophis. It's dangerously close to the Earth. So we just need to cross our fingers. That's pretty much it at this moment. Is it like dangerous? Yes, 100%. Even though we calculate, double check, triple check so many times, you can't control these things, right? So they might get a little hotter, warmer. There could be some kind of a gas on these asteroids that some ice might melt, some vapor can come out, and it can change the direction. So no matter how much you calculate, it all goes to, I guess, dust. If we, yeah, you are right. Aliens are united yesterday. We collectively didn't see anything. The reason why you guys didn't see anything, or I didn't see myself anything, is because one, it is too dull. Two, it went to the little bit more west. It is supposed to be like this is the region that it is supposed to be the upper region. Let me bring that screen. It is supposed to be right here where it is supposed to be like right in this location. That is where the Einstein crater is. Unfortunately, it went short a little bit, not a whole lot. And that place, wherever it's shot, you won't be able to see a picture. Did it happen or was it a hoax? It sounded like a hoax, Tammy. That's really what happened, because I was surprised that like so many people were tuned in, and I mean, now we are getting information about like second-hand information, but probably I would say this is not a hoax, 100%. The reason for that was I think we are getting better and better at getting latest and greatest information. Lot more people are tuning in. I believe that is playing a lot of role. I mean, think of 5 years ago, how much were we aware of a man-made rocket impacting the moon? Probably we might have, but are we all collectively tuned into it? I don't know. I don't think so. So I think now you are right, Kronos. I guess the power of social media, internet, I guess, all these things are making us connected, and now we are all collectively tracking this thing. We're getting better. I think so. I mean, that's how it feels to me like. So this could have been the similar experience for some people who are sitting remote in a lab watching it. Okay, I didn't get any data, they'll come tomorrow morning. But now it's not that scenario anymore. It's like the whole world is watching live, literally. So you guys, I mean everyone, all of us, we are using our backyard telescopes and watching them. So we are keeping them in check. So things that people used to hide before, probably they can't hide anymore like the way they comfortably used to, because now we have additional evidences that will come out and they will tell the truth. So by the way, if you are looking at the picture on the side, I'll see if I can close some of these. Right. So that's the comet that it is taking pictures. You have a screen in front of you, right? So yeah, I'll move the screen to the right. Yeah, that's what is going on there. Yeah, let it do its work. That's what is going on there. Oh, the Russians stole it. Oh, thank you, thank you. No, I'm glad you guys are all part of this deal. You all connected, came in, and I think we did a pretty good job last night. So guys, I'll be taking these pictures. I don't mind keeping the stream on if you all wanted to watch the stream. Let me check if I have any more data that is coming in. Let me check if there is any more data that is coming in. Oh wow, this is something very important to know. So it did send out quite a lot of energy into the sky. So yeah, that's pretty much what the data I was able to collect so far on this one. I think we'll get a lot more data. Thank you everyone. So if you just joined the stream, please do subscribe. I don't mind keeping the stream on because I will be taking pictures anyway, because I want to take the comet pictures. If you stay live, you will be seeing over a period of time a bit more green comet, because right now it is still coming up in the horizon. So I'm going to leave the live stream on. I'll keep the music on. I'll stay off on the audio and the video. I'll come back here maybe a bit later and check it out. After that, the moon is going to come around 12 o'clock, maybe an hour and a half from now. And that time I'm going to turn this off because I don't need to take the pictures while the moon is illuminated. It's not going to look nice anyway. By the time I'll get enough data. So that's the plan for now. Let me know if you guys have anything else. I am working on a brand new video. You guys will see it hopefully tomorrow or day after. It's taking time because of all these other things that came up in between. Thank you, Jason. Thank you, everyone else. Yeah, if you are going to stay on the stream, please do. I'll monitor the live chat once in a while.